And may the odds be ever in your favor. Never mind. All right. The blue square as the pre-image, write two algebraic representations, for one for the dilation to the green and one for the dilation to the purple square. So we know the blue one is right here in between, and that's the original one, right? The pre-image, and then the image is either the green one or the purple one. So what would be an expression, an algebraic representation for the green one? Okay, 2 times x and 2 times y, right? That's the rule basically, and that's all it does. What about for the purple one? Time. So all you can do 1/2 times x, right? And then 1/2 times y, and that's the rule for the purple one. And that's it. Very simple, right? Not overly complicated, just simple enough to understand. A triangle has vertices, bigger story, A, B, and C. The center of dilation is the origin. Generally speaking, the center of dilation will always be the origin for this class. What are the vertices of the dilated image? The rule's right here, so what do? You multiply it by 3, right? It seems like the scale factor is 3, so you multiply everything by 3 and you get your new, so A will be what? And B prime is what? And C prime? There we go, beautiful. That's it. That's all you have to do. Give me the new coordinates. M and OP prime have vertices at blah, 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 and blah. The center of dilation is the origin, once again. Usually it's the origin. M and OP has vertices, blah, 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 and blah. What is the algebraic representation of this dilation? What do you do here? Or what did you do here? How do you find the rule? Okay, that's a good strategy, but I don't want to deal with decimals because they're crazy. I can use the next one, right? And you always divide which one by which one? The prime, right? By the image. So you always put prime by, no you don't. It's the opposite. The image by the prime, sorry. I over P, right? I over P. The image by the prime. So the image is what? No, why are you confusing me? That's what it was. It's the image by the pre-image. There you go. Okay. So what is the value for the image? Hello? 6. And what is the pre-image? 9. I'm using the wrong terminology here. All right, so what do you get? Why are you giving me 3, people? It's 2 over 3, right? You simplify it. If you put the pre-image and divided it by the image, you did it wrong. You're dividing the new one by the old one, right? The image by the prime by the first one. So just to make sure that we're doing it right, let's use another point. 4 and 6. 4 over 6. Image over pre-image. You get 2 over 3. So what can we conclude after that? What? The scale factor is 3 over 2, 2 over 3, right? So how do you write the algebraic representation? There we go. If you put 3 over 2, it's wrong. Here's another clue that you can figure out very easily. If the numbers from the pre-image to the image are increasing, then you should have a whole number or above. But notice that they're decreasing, right? They're going from bigger numbers to smaller numbers. That means the image is shrinking, which means that you should have a fraction, yes, or a decimal. If you didn't put the dot, yeah, if you did not put the dot, that's fine. You're automatically assuming that you're multiplying if there's nothing in between. All right, do you feel better? Congratulations. All right, a dilation with center 0, 0, meaning at the origin. Then a scale factor of k is applied to a polygon. So let's pretend there is a polygon. It could be any shape that is a polygon, right? But this dilation of the center, and it says the scale factor is k. So if the scale factor is k, what is the rule? Times x, right? And k times y. That means k could be any number they give us, right? We don't know, but it's just k. What dilation could you apply to the image, this one, to return it back to the original? Huh? What would it be? Flip it. There you go. Basically the fraction, the opposite of this. Remember that if you multiply by 3, to go back, you divide by 3, right? So you multiply by 1/3. So it'll be just 1 over k times x, and then 1 over k times y. So to give you an example again, if this was 3, you would multiply by 3, right? To go back, what would you have to do? Divide by 3. But because we don't divide, that means you multiply by 1/3, right? So that means it would be 1/3, 1/3 right here. Is it confusing? A little bit? So basically, it's kind of like they call it naked problems in a way that doesn't give you much information. You have to kind of like think about it. It's saying that if the scale factor is k, and it could be any number. So let's say that we're using k right here, using 3 instead of k. Do not lose me. We're using 3 instead of k, right? That means we're going to multiply all the values by 3. Got it? Let's pretend that this is 2, the x is 2, and the y is 2. So 2 times 3 is 6. 2 times 3 is 6. So that'll be a new coordinates. How do I get from 6, 6 back to 2, 2? By what? Did we divide by the scale factor? We multiply by it, right? So what do you have to do? What do you have to multiply by to get back to it? By 1/3, right? By the fraction. Basically that, 3, but flip it into a fraction, right? So that means you multiply 6 by 1/3, and you get back to 2. And then 6 by 1/3, you get back to 2. So that means you'll get right here 1/3 times x, and 1/3 times y. And over here will be 2 times x, or 3 times x, and then 3 times y. Those are the examples. I know it's a little confusing, but just understand that if you multiply, the scale factor is a number that gets you bigger. To go back, it's just the same number, but put a 1 on top. And that's it. That's it. It has to be a fraction, because you're reducing. You're not increasing anymore. Got it? I hope you do. If you don't, that's fine. Go back to the video. Yes. The what? No, that's different. I'm saying the scale factor of 1 doesn't change the shape at all. But we did change it. You use the scale factor of k to change it to something, and they're asking you, how do you return it back to where it belongs? Well, by doing 1 over k. Basically doing the opposite. You still don't get it. Kind of. All right, let me do one more over here. If we are, let's say we have the coordinate point 3 and 4, and the scale factor is not k. Let's say the scale factor is 2. So what is the rule? Are we good so far? So let's apply it. 2 times 3 is 6, right? 2 times 4 is 8. Well, I want to bring this back to this one. What do I need to do? We don't divide by the scale factor. We never divide by the scale factor. What do? We multiply it by half. So that means we have to apply another rule here, which is half times x and half times y. And that will give us back to 6 times 1 is 1 divided by 2 is 3. 8 times 1 is 8 divided by 2 is 4. We go back to the same one, right? But what do we have to do to the rule? Turn it into a fraction, right? Using the same number. That's it. It was 2, and now we switched it into 1/2 because we needed to go back. Do you have a better understanding now? Good. It turns into the denominator, yes. All right, so let's move on and get the other one. The last one was pretty tricky. People were like, what? All right, so where'd it go? Oh, wait a minute. The blueprint for a new house are scales so that 1 inch equals 1 foot. I'll make note of that because that's important. 1 inch, wait, 1/4 of an inch. What is wrong with me today? 1/4 of an inch equals 1 foot, right? There. The blueprint is the pre-image, and the house is the dilated image. So the blueprint is what you have here, and then it dilates into the actual house. By the way, tomorrow you're going to have a little project very related to this. It's going to cover scale factor and scale drawings. And it's going to be, you're going to work in teams, and you're going to recreate this entire room. So you have to measure and then use the scale factor to bring it to a smaller version of it. Do what? Yes, you're going to measure it. It's called discovery learning. That means you do it on your own and you discover it. Oh my goodness. Irrelevant. We'll talk about it tomorrow. All right. The blueprint of is the pre-image, and the house is the dilated image. The blueprints are plotted on a coordinate plane. What is the scale factor in terms of inches to inches? What is the scale factor in terms of inches to inches? 1/4 is to 1 foot, not to an inch. What? How do you get that? Did anybody do 48? Well, how do you do it? Well, you can just tell me. It's very easy, actually. What did you do? 1 foot, yeah? That's it? That's literally it. They're asking you inches to inches. So you put inches, not to feet, but to inches. So how many inches are in a foot? That's it. And you can. So what do you do now? If the image goes on top, right? To get the scale factor, you get the image. So it'll be 12 over what? 1/4. What is the decimal form of that? 0.25. When you divide it, you get 48. So yes, the scale factor would be 48. You will have to multiply 1/4 times 48 to get 12 inches. Well, what? Oh, not yet. You won't need it now. All right. Do you have any questions on this one? Huh? Yeah, the last one was pretty tough. Okay. 1 inch on the blueprint represents how many inches in the actual house? 48. 1 inch equals. Are you sure? Hang on. This is, wait, oh, how many inches in the house? Wait, 1/4 of an inch equals how many inches? No, on 12, right? 12. I'm using this because it's important. Hang on. If we're talking about how many inches, how many would be for 1 over here? What do? That's called proportion. We're going to use that too for the other lesson. So if you know what equals to what, and then you're looking at the whole inch, because that's only 1/4 of an inch, right? If 1/4 of an inch equals 12 inches in the actual house, how many full inches will equals to that in the actual house? Well, you cross multiply and divide, and you get 48, right? The same thing works with the other one, with the feet. What do y'all get? 4. You can just divide that by 12. Or you can do the proportion. Do what? Or she lost me. I'm sorry, you lost me. All right, write an algebraic representation of the dilation from the blueprint to the house. What is it? Uh, 48x. There you go. And this one comes from this guy right there, right? Oh, I'm sorry. I thought you were talking about the other one. Oh, I'm sorry. You were ahead of us. All right. A rectangular room has coordinates blah, 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 and blah on the blueprint. Careful. We're talking about the room now, not the whole house. The homeowner wants this room to be 25% larger. What are the coordinates of the new room? Wait, what is the first one? By the way, for those of you who don't know, how do you get 2.5? That's it? When you multiply 2 by 0.25, you don't get 2.5. Then add the original number? Okay. So when you're talking about percentage, if I want to add, let's say that I have, let me put it on the side. Let's say that I have something that measures or weighs 40, and I want to increase it by, let's say, 50%, because that's easy. How do I increase that by 50%? Yes, multiply by zero point 0.5, and that will give me the amount of increase, which is 20, right? And then add this back to that. That means 60. Notice that I'm actually increasing from 40 to 60. The problem that some kids have is that they multiply the coordinates by 0.25, and they didn't add the other one back. They left it as 0.25. Who's painting their nails? Oh, that's you. Throw it away before I take it up. I can spell it. You're not supposed to have it here. Okay. So here's another way to do it without having to go through all that. If you're going by 50%, you know you're gonna have to go back and add 100% of the other one, right? So you can just add them both. 150%. Turn it into a decimal, it's 1.5. So you can just multiply every value by 1.5, and it's gonna give you the correct answer. In this case, you could just multiply everything by 1.25. You look confused. Where? That if you don't understand percent, which is up there, that means you guys did not learn that last year. And that's not good. Okay, so I'm going to use proportion to do that. Proportion is a really cool thing that you can use in a lot of places. I want to increase by 25%, right? We usually do P over W. And then on top you put the percentage, and on this one you put, let's say, the coordinate. So what percentage am I increasing by? 25, right? 25% out of 100, right? And then the whole will be 2. We're going to use 2. And that's x. We don't know what that is. You cross multiply, and you get 100x. And then right here you get 50, right? You divide by 100. Divide by 100. What do you get? 0.5. Which is half, right? It's a half of 1, so it's a quarter of this. But you don't 1.5. You got to go back and add what you had originally, right? So you have to go back and add the 2. So 2.5, that's what you do. Why? Because they're increasing by 25%. That means if I tell you I want to increase her grades by 25%, that doesn't mean that I'm going to multiply by 25% and I'm going to get a lower number. Am I increasing that way? I'm going lower, right? That's why you have to go back and add it to the original one. Otherwise, you're going to get just 0.5, and that's not increasing. You're not going up from 2 to 0.5. You're actually going down if you do it that way. You have to go back and add what you already had. All right. Good. All right, Micah, go back to R prime. Okay. And then S prime, 6.25. And the last one, which is T prime. And that was it. All they did basically was find the scale, the increase, which is 0.5 for these. And then for those, it was 1.75. And then for the other one, for 5, was 1.25, right? And then add it back to it by doing proportion or just by multiplying 1.25. I'm going to have to explain proportion separately because you're going to need that later on. Okay. Once you have this, the last one makes more sense. Yes. Did you get it? What do you get? And so what do you say again? These are inches, right? And then the feet, what was it? Good job. I'm seriously impressed. I think this is the first time that you beat the first period. Nobody in there got it. Did you get it too?
No, I didn't get it.
All right, Micah, explain how you got this. Just half the kids are like, what? Hey, how do you get it? What graph? What graph? Did you graph it? There's a graph there? Okay. No, I'm waiting for you to tell me how you got these numbers. How do you get 6.25 and 3.75? Because half the class doesn't know. Yes. Yes, you're supposed to use the answers from D to get that answer. Did you do this yourself? Okay, Ayana, how do you get it then? How did you calculate it? We were there. We were on D and then we were on E. So I want to know how you got it. So I take it back. This period did not beat you on that one. First period, if you're watching. They actually just copied the answer from Christine. Good job, Christine. Shout out to you. Let me explain how we got the right answers for this one because it was not a very easy problem. You actually have to think about it. You either have to graph it or figure it out. So they're telling you how to find the dimensions of the blueprint using the numbers above. Well, let's just use one. The image, which are these, let's use R. R is 8.75. Hang on. And 2.5, right? And then, well, no, that's not how we did it actually. We have to first of all identify what the shape looks like. So let's assume that Q is right here, Q prime, and then R prime is right over here. And then S prime, notice that S prime and R prime have the same X. That means they're on the same line. So S prime has to be right here. And then T prime has to be right below as Q prime because they have the same X as well. That's T prime. We want to find a distance from here to here, right? How do you find the distance from R to Q? Let me put the numbers on it. This is 8.75 for X, right? And this is 2.5 for X. Easy, right? When you subtract, you actually do get 6.25. And for this one, to go from, I think it was the Y, you do the same thing. You basically subtract this one, well, not this one from the other one, and you get 3.75. You do exactly the same thing. This was not an easy problem. I want you to understand it, not to get the answer from them. I'd rather you come to my class with a blank answer saying, I really tried, I didn't get it, than bringing an answer that you did not get on your own. Because that really constitutes as cheating. You're literally cheating. Yeah, you have to create the thing and then you subtract the values, and that's it. The what? The same way, but you use the y's instead? Yeah. Because one of them goes up and the other one's to the side. Did you get your little pass? Did you get your little pass? Okay, good. And then how do you turn this into feet? By what? What was the skill factor? Inches. What about feet? 4 feet, right? If you're looking for the feet, just multiply those by 4. And that should give you the answer. You see that? It's a very tough problem. But you either have to graph it or actually just do it algebraically. I wanted you to do it algebraically, the way that I just did it, by subtracting the values, because sometimes you won't be able to graph. And when you graph decimals, it's extremely difficult for you to count the distance if you have decimals, because you're not going all the way. You're going to the fractions of the decimal. I mean, of the distance. All right, so let's move on to the next part. All right, so we'll take the last few minutes working on these. I will give you about 2 minutes to answer both questions, and then we're going to discuss them. You don't need to. So what's the answer for number 1? What is the measurement of x?
6.
How do you figure that it was 6? Ah, good, good, good. All of you are right, but I want you to hear the mathematical term scale factor. Because scale factor has everything to do with similarity. It's just like dilations. Okay? Similarities have a scale factor, all of them. It's just a dilation of each other, right? So to find the scale factor, you divide the image by the pre-image, right? And you get 2. So you multiply everything by 2, and you should get the measurements of the image. And that's right. That's it. That's all you have to do for that one. This is given that they are similar. I want to tell you, these shapes are similar. What is the value of x? Yes. Similarity is a big part of it. What about the next one? Again, you divide the image by the pre-image, and you get 1/3. That's the scale factor. What else do you notice about it? You divide them by 3, right? If this one goes with that one, you notice that 9 was reduced by, in 3s, right? So you have 1/3. And if this one corresponds, meaning that it goes with this one, it increased, but well, it doubled, right? You basically made it double. You multiply by 2, and then you get the new one, right? That's basically all it did. How about the perimeter of the one on top? Kat, what is the perimeter of this one right here? I'm asking, like, what is the perimeter of this? 10. This is 3. This is 2. So the perimeter equals 10. What is the perimeter of this? 4, 6, 4. It's 20. The perimeter is 20. What can you tell me about that? What is the relationship there? The scale factor is still used, right? So now, well, let me see if it always works. Let's try this one. What is the perimeter of this guy right here? It's not 24. 24. Oh, sorry. 66. Whoa. What about this one? This is easy. 22. So tell me, does the scale factor still work? If you multiply by 1/3, you get 22. So now we can conclude that the scale factor can be used to find the new coordinates, like we did earlier, to find the new measurement, like we just found out right now, and also to find the perimeter of each shape. Yes, it can be a fraction if it's reducing, and it can be a whole number if it's expanding, right? Yes. What? The perimeter? No, the perimeter is different than the scale factor. Well, guys, we're not done. Yes, a lot. No. All right. So for what do you think the area would work? What is the area of this? What is the area of this? 24. Does it work? 6 and 2 is not 24. But one of them? Okay, hang on. Let's do this one. What is the area of this? What? 216. What is the area of that? 24. Okay. So look at it. How do you get from 6 to 24? Times 4. Oh, wait a minute. So the scale factor was 2. But for the area, the scale factor seems to be 4. In this case, the scale factor was 1/3. For the area, I'm just going to tell you, the scale factor is 1/9. What is the relationship there between the scale factor for the regular and the scale factor? What is that? What do we call that when you do that? That's square root. We square it. Yes. Hang on. The what? Where? For the scale factor? No, because you're not multiplying by 3 to get that one. You multiply by 1/3. It's decreasing. What do you think that you have to square the scale factor to find the new area? Think about it. Why do you have to square the scale factor to find the new area? Ah, that's it. Very simple. Because the area is measured in squared, right? It's squared. It's two-dimensional. What do you think will work? Do you think it will work for cubic? We can try it tomorrow. We can see if we can use the scale factor, cube it, and see if it gives me the new one. Ugh. Hang on. No homework, guys. Just make sure that you're ready for tomorrow's project.